Welcome to lesson number 4, solving inequalities with positive coefficients. And a coefficient, if you recall, is the number that's paired with a variable. It multiplies the variable, so it's a coworker with that variable. So let's continue. When we're given inequalities with positive coefficients, we solve them just as we would solve an equation. We just need to remember to include the given inequality sign. After finding the solution, we're going to choose a number that makes the inequality true. Then we're going to use that number in the original inequality to check. So let's get started. The very first inequality I see says 8x is greater than or equal to 56. So my solution is not 56. I have to figure out what x equals, and I'm going to do that just like an equation. I'm going to build the wall over the inequality sign. I'm going to divide by 8 because that's the coefficient. I'm doing the opposite of multiplying by 8. So I have to do this on both sides. So now what I have left over is x on this side, and on the other side I have 7. But it's really important that I drop down this inequality sign. So now my solution is x is greater than or equal to 7, and it means all of the numbers that are greater than are equal to 7. Now I could check 7, but that's really not going to help me. When we have an inequality that includes an equal sign, we want to choose the inequality part, the comparison. So I need to check a number that's greater than 7. So I'm going to choose 8. And I'm going to use the original inequality. It starts out with 8 times a number. So I'm going to use 8. And since 9 would be larger than 7, if I choose 9 here, it is larger or greater than 7. I'm going to go ahead and choose 9. And the rest of this inequality says that this is greater than or equal to 57. So I'm going to write, 56. So 8 times 9 is 72. And when I use a number or substitute a number that meets this inequality, it is true. 72 is greater than or equal to 56. So now I'd like you to try the next one on your own. Please tell the solution for 7n is less than negative 42. When we solve this, the solution is n is less than negative 6. And now we need to use the original inequality and choose a number where n is that would indeed make this inequality true. What number do you think we could use? Negative 10 would make this inequality true. 7 times negative 10 would be negative 70, and that is less than negative 42. Just recall that the further a number is away from 0 to the left of 0, the smaller it is. So negative 70 is indeed smaller than negative 42. Let's go on to the next. This inequality says a divided by 5 is less than 3. So in order to solve this, I have to do the opposite of dividing by 5. So I'm going to build my wall. I'm going to multiply by 5 on both sides because that is the opposite of dividing by 5. And then I'm going to have a is less than 15. So in order to do the check, I have to start with a number that is less than 15 that I can divide by 5 that is going to be less than 3. I'm using the original inequality. I've just left this blank because I'm waiting to choose a number. So I'm going to choose a number. Since I'm dividing by 5, I'm going to choose a number that's easily divisible by 5. So I'm going to choose 10. 10 is less than 15, but it also is divisible by 5 evenly. So if I take 10 divided by 5, I'm going to get 2, and 2 is less than 3. So when you do your check, you go back to the original problem, original inequality rather, and then you choose a number that meets the solution answer. So I chose 10 because it's less than 15, but I used the original inequality to check that answer. Let's move on. Please solve this inequality on your own. It says y divided by 6 is greater than 4. What is the solution? The answer is y is greater than 24. We multiply both sides by 6. That's the opposite of dividing by 6. So now we're going to do a check. When we do a check, we go back to the original inequality that's given. So some number y that's greater than 24, if we divide it by 6, would be greater than 4. So what number could we replace here and then divide it by 6 and have it be greater than 4? If you said 30, that would be correct. 30 divided by 6 would be 5, and 5 is greater than 4. So now let's go on to two-step inequalities. When I solve two-step equations, I have two numbers that I have to undo. I have a coefficient and I have a constant. And we work backwards from the order of operations. We undo the number that's being added or subtracted, the constant, and then we undo the number that's being multiplied or divided, the coefficient. So we're going to build our wall, and I'm going to take away 8 on both sides. And what's left is 4y on this side, and this is where I have to be careful. This is like adding a negative 36 and a negative 8, or in your calculator, if you enter negative 36 minus 8, it's going to give you negative 44, either way. And I just noticed that I don't have the inequality sign, so sometimes I have to catch myself and focus a little bit more when I'm solving these. Next, we're going to continue solving by dividing by 4 on both sides. This is going to cancel, leaving y is greater than negative 11. So this is called our solution. So now we're going to try to do a check, and because there's a little bit more going on, I'm going to go ahead and write out the full equation. This is what we were originally given. I need to come up with a number, or choose a number that's larger than negative 11 and substitute it where this y is. And then if my solution is correct, I will have a true equation, or true inequality when I get done. So negative 10 would be larger than negative 11, and that should be an easy number to work with. So I'm going to start with 4. I'm going to replace y with negative 10, and then the rest of the equation, inequality, says I should add 8, and this left side should be larger than negative 36. So continuing, if I take 4 times negative 10, I get negative 40. I'm going to add 8 to that, and that should be larger than negative 36. And then I'm going to add negative 40 plus 8, and I'm going to get negative 32 is greater than negative 36. Now, I don't know about you, but when I work on the negative side, I really have to focus on this. Negative 32 might look smaller than negative 36, but on the number line, it's closest to 0. It's closer to 0 on the left-hand side, so this number is indeed larger than negative 36. So please try the next inequality on your own. What is the solution for 5x minus 9 is greater than 36? The solution is x is greater than or equal to 9. And so I need to choose a number that's greater than. I could again start with 9 because that would satisfy the solution to this equation. However, we want to check a number that's greater than 9. What number do you think we could use to replace x with in the original equation that would make this true? 10 would satisfy the solution. It's greater than or equal to 9. And when it is substituted in the original equation, we come up with 41 is greater than 36, which means that, yes, this is true, so therefore our solution is correct. Let's move on to the next set. This set is also two-step equations. Our goal is to try to undo dividing by 2 and undo adding by 4. So I have two numbers that I'm trying to mathematically undo. And we do that using the inverse operation. So I'm going to start by building my wall. I'm going to subtract 4. I start with a constant first. That eliminates the constant. So I'm left with x divided by 2 is less than or equal to 8. So now I need to continue my solving step. My goal is to try to undo divided by 2, and the opposite of that is to multiply by 2 on both sides. And this eliminates the 2, leaving my x is less than or equal to 16. So this is my solution. Once again, when we check, I have to start with the original inequality that they give me. So I'm writing exactly what they gave me initially. So now I'm going to replace x with a number that is less than 16. Or it could be equal to 16, but that's not going to help us check the solution. So I notice I'm dividing by 2, so I'm going to choose an even number. So I'm going to go ahead and just erase that, and I'm going to choose, let's make it 14. 14 is less than 16, and it also is evenly divisible by 2. I wouldn't have to choose an even number. I'm just trying to make my check a little bit easier. So 14 divided by 2 would give me 7, and to that I'm going to add 4, and this should be less than or equal to 12. And 7 plus 4 is 11, and 11 is indeed less than or equal to 12. So that means that my solution is correct. When I chose a number that satisfied my solution and replaced it in the original equation, I did indeed get a true statement. So would you please now try solving this inequality? What is the solution? The solution is n is greater than or equal to 27. So now let's again write down the original inequality, I think I said equation. So this is what they gave us originally, and I want to know what we can replace n with and divide it by 3, then subtract 5 from that result and have that result be greater than or equal to 4. What solution number would work? If you said 30, you're correct. 30 divided by 3 would be 10. 10 minus 5 would give us 5, which is greater than or equal to 4. Okay, let's just explore the next set, and then we're finished. I know this is a long lesson, so hang in there with me. Thank you. So for the following inequalities, you can solve them as written, if you're okay with your variable being on your right side, or you can switch sides. However, you must switch the directions of the inequality sign if you switch the order of the sides. When it's an equation, it doesn't matter, but when it's an inequality, it absolutely matters. So this says 57 is smaller or less than W minus 34. So this is the smaller amount value, this is the larger amount or value. So if I switch sides, I have to rotate everything. Excuse me, not everything. I have to take exactly what I'm given on the right-hand side, and I'm going to move the 57 to the left-hand side, but this sign must reverse because this value is larger than this value. So now I'm showing that whatever is over here is larger than 57. That's and that also means the same thing as 57 is smaller than W minus 34. So we're not going to continue to solve, but I would like you to go ahead and rewrite this inequality if we switch sides. Show me what it would look like if we switch sides. if we switch sides with what we're given, this inequality sign would have to switch to its opposite. Thank you very much for listening. Take care.